So given a vector function, r of t is f of t, g of t, h of t, the derivative, which we're going to denote r prime of t, is exactly what you think it should be. It's just r prime of t is f prime of t, comma, g prime of t, comma, h prime of t. And the reason why this is the case is because of the definition of the limit that we gave just a little bit ago in the last video. So what I want you to think about, though, is what does this mean? Like, what's the meaning of the derivative? Before, the derivative gave us a slope to a tangent line at a point. Now we've got this curve in 3 space, and we're getting out a vector. You plug in a t, and you get out a specific vector. And so the derivative of a vector function gives the tangent vector to r of t. And the tangent vector, of course, by default is not slid where its tail is resting on your function. But if you have a specific t value, let's say t naught puts you right here on your curve, and you were to graph, let me get this thing down here. Yeah, something like that. And you were to graph the vector r prime of t naught, and you were to put its tail at this point, it's going to be representing the tangent vector. So if you were to lay a tangent line on this curve, even though we're in space, we can still talk about tangent lines. And so quite literally, the derivative of a vector function gives you the tangent vector, or the direction vector of the tangent line to the curve at that point. And so let's practice first computing a derivative, and then we'll actually work out a tangent line and look at it in Mathematica. But just to make sure that we're clear on the derivative taking, boy, this is just Calc 1 basically 3 times. So r prime here is going to be 3t squared minus 1 minus e to the minus t, and 1 over t, done. Not so bad. All right, so we want to go to another example, and let's find the vector equation of the tangent line to our favorite little spiral at this specific point. And I want you to realize this point is the same as root 2 over 2, root 2 over 2, pi 4. So I'm perfectly happy with the root 2's downstairs, but just want to make sure that's clear. So the first thing we need to realize is that I've given you a point on this vector function, a point on the space curve, but I didn't tell you which t value it was. In this case, it's pretty easy because, look, you just solve for t, but in general, you might have to solve all 3 of these, right? Sine t equals this, cosine t equals that. That's enough to actually get the answer as well, but here it's pretty easy because z is just t. So we immediately see that we're interested in t equals pi 4. That's the t value that's driving this thing. And so what we're going to do is we're going to go ahead and compute the derivative. So we're going to get r prime of t is what? Well, minus sine t, comma, cosine t, comma, 1. And now I want us to think about the value of the derivative at the point t4. So not r prime of t anymore, but r prime of, I said t4. You knew what I meant, pi 4. R prime of pi 4. This is what? Well, let's just be super clear. So this is minus sine of pi 4 minus the cosine of pi 4, comma, 1. And this is exactly what? Minus root 2 over 2 cosine. Oh, sorry, I have a minus that just showed up there. I don't know why I did that. A minus root 2 over 2, root 2 over 2, and 1. So that's my direction vector. Let's go ahead and say this. This is my direction vector. And now I need r naught. I need a point on the line. I'm actually not going to use r, though, because we labeled this particular vector function as r. So my point on the line, which I'm going to think of as a vector, point on the line, this was given to me, and the point that we're going to use is 1 over root 2, 1 over root 2 pi 4. And at this point, you're just literally writing down the equation of a line. That's it. I'm going to use a different letter. I'm going to use curly L. I don't want to use R, which we usually use for lines because I've used it here. So L of t is, here we go, 1 over root t, that's this one. And then you say plus this times t. So minus root 2 over 2 times t. Kind of funny that we have this, and I'm writing one with root 2 downstairs and one with it not. Whatever, you can change it if you don't like it. The next one, we get root 2 over 2. I'm going to switch this one. Root 2 over 2, and then plus root 2 over 2t, and then what? We get pi fourths plus 1 times t, which is t. And the claim is that this is actually the tangent line. And so let's switch to Mathematica and have a look and see if this actually works. I'm sure you've noticed the sound quality goes down when I switch to Mathematica. I've not been able to get my microphone to work on my laptop, and yeah, it's not great, but it's the best I can do right now. Well, here's our space curve, the same one that we did before, and I've tried to orient to our usual perspective, and you can sort of see that tangent line right at that point. So it's the same kind of tangent line that you're used to, it's just all three-dimensional now, and it's kind of fun. So there you have it.